Good afternoon. I hope that everything yesterday made sense and that you're ready to think really hard today and do some good physics. Yesterday we had been talking a whole lot about impulse and momentum and changing velocities and the amount of force that it takes for those things to happen. But what if you don't know the new velocity and an impulse is given? What you need to do is be very, very careful of the direction that the force is coming in. So far we haven't really drawn diagrams, but I do want to draw a little bit of a quick diagram. They don't have to be difficult, they don't have to be elaborate, just a little bit of something to get a sense of which way is positive and which way is negative. So let's write out this problem. Suppose a 0.2 kilogram softball is met with a 520 Newton force for 0.35 seconds in the opposite direction of its motion. How fast and in what direction will the ball be going after the impulse? Okay, so let's just get a little bit of a sketch going here. We've got the softball. Softball is going this way. It's 0.2 kilograms. And we do need a little bit more information. We need to know how fast that softball was going in the first place. So let's just add that information. A 0.2 kilogram softball going 35 meters per second. Okay, is met with a 520 Newton force per 0.35 seconds. In the opposite direction of its motion, how fast and in what direction will it be going after the impulse? So we have our softball, and it's going in this direction. It happens to be going 35 meters per second. Alright, and it's met with a force, a 520 Newton force in the opposite direction. So I'm just going to sketch in some arrows here. So we've got this is the 520 Newton force this way. So in order to set up our positives and negatives, you have to set yourself, choose which way is going to be positive. So I'm going to say that the initial direction of the motion of the softball is positive. Okay, you have to choose something because this drawing right here tells you that this is going with positive, this is going against positive, so this would be negative. So we have to make sure that you have your positives and negatives correct in the equation, or you're not going to get the right answer. So let's look at our impulse momentum equation. Okay, force and time. So you have a 520 Newton force, and this force is negative. Positive direction of the ball, force is in the opposite direction of its motion. And it does this for 0.35 seconds. Okay, then we have the later momentum minus the earlier. Alright, so we don't have information on the later momentum except we do know the mass of the softball. So we know that it's 0.2 times that later velocity that we don't know. We do know that earlier we had the 0.2 kilogram softball, and it was going at positive 35 meters per second. So now we need to figure out the new velocity of the softball based on this information. So let's take our 520 times 0.35 and find out our impulse is negative 182. And we have 0.2 times the unknown velocity minus 0.2 times 35, 7. Alright, so then we have to add the 7 to both sides, and we get 0.2v and that gives us negative 175. So our new velocity of the softball, okay, this happens to have been an extremely powerful bat. Probably wasn't a bat at all, because it's going super fast. It's going 875 meters per second in the opposite direction. Okay, so very unrealistic as far as the result. This is actually a very long time for that bat to be in contact with the ball. But this is what would happen if that much force was delivered for that much time. As small as the time seems, it changed direction and had a huge difference in its velocity. Okay, so it's not only going in that much speed, it's going in the opposite direction. So you would say as a final answer 875 meters per second in the opposite direction. Okay, so we're going to go ahead and move on. Okay, oops, I think I meant to put that one up there. We have another new question that I want to take a look at. Let's have a baseball. Okay, this baseball, 0.144 kilogram baseball, and I actually took that from the book and figured that that one's closer than my estimates. It's pitched at 25 meters per second and is hit by the bat so that it's going 35 meters per second in the opposite direction after the impact. So let's get this question written down. Suppose a 0.144 kilogram baseball is pitched at 25 meters per second and is hit by the bat so that it is going 35 meters per second in the opposite direction after the impact. And then part A, what is the change in momentum of the ball? Okay, so we have that. So we need to actually go through and start to evaluate the situation. We may need to draw ourselves a little picture so that you get your positives and your negatives in the right way. So let's do that. We have the ball initially going this way at 25. We'll set this direction to be positive, and then afterwards the ball is going this direction at 35. And this is just to remind you, even though it's just something little, it's just so that you remember to look and figure out whether the numbers should be negative or positive. So change in momentum, P2 minus P1. Later minus earlier. Okay, so later it's going 35 meters per second, and the mass is 0.144, but it's going in the negative direction. So the mass being 0.144, it's times negative 35. And then minus the earlier one, 0.144 again, because it's the same ball, but this time it's times positive 25 meters per second. So we do a little quick calculation here, and we'll figure out what the change in momentum of the ball is. 0.144 times negative 35 minus 0.144 times 25. And we get negative 8.64. Okay, so that's our change in momentum, and it's technically kilogram meters per second. Okay, the impulse on the ball. Okay, some of you might remember from the beginning of this lesson, I hope, that impulse equals change in momentum. So there is absolutely no calculations to do on this whatsoever. Okay? You can leave it as kilogram meters per second, or you can write it as Newton seconds. These units are equivalent. Usually we think of these units when Newton seconds when you're talking impulse, but it really doesn't matter because they're really the same unit. Alright, so if the ball's in contact, if the bat's in contact with the ball for 0.9 milliseconds, what's the force applied to the ball? Okay, so we're trying to think through F delta T. The impulse equals negative 8.64. Now the problem is that my delta T is in milliseconds. So we have to remember our conversions. Okay, as far as milliseconds go, so we have 0.9 milliseconds. Okay, there are 1,000 milliseconds in a second. Just like there's 1,000 milliliters in a liter, 1,000 milliseconds in a second. So you're really dividing that thing by 1,000. 0.9 divided by 1,000. .9 divided by 1,000. Which gives you 9 times 10 to the negative 4. Equals negative 8.64. And then what we need to do is divide both sides by that to get our force. Okay, remember this doesn't have any positive or negative, but our force has got to be negative. That makes sense because the force has to be in the opposite direction to change the direction of the motion there. So we have 8.64 divided by 9 times 10 to the negative fourth, and we get 9,600 newtons. So quite a lot of force to be hitting that ball with to do that change. But once again, you won't get the right answer if you're not careful with the signs. So be very, very careful. The signs matter a lot in these problems. So just one quick little drawing should solve any problem that you may have on that. Okay, we have one more to take a look at, I believe. Okay. Let's say you have a 0.5 kilogram polo ball. Okay, polo is that game where you sit on the horse and you hit it with that mallet, and it's going 15 meters per second. It's hit by a mallet from behind, so it's going 38 meters per second. We want to find out the impulse on the ball. Okay, now this time it doesn't ask that sub-question, but remember, impulse can actually equal P2 minus P1. Okay, so P2, the later one, minus the earlier one. In this case, we have the initial condition is 15 meters per second. If we set this direction to be positive, later on, it's going 38 meters per second. And so, later condition, excuse me, later condition would be 0.5 times 38, and the earlier condition 0.5 times 15. So the impulse, 0.5 times 38 minus 0.5 times 15 equals 11.5. Makes sense that this comes out to be positive because the impulse has to be in the same direction in order to make it so that it's going faster. Okay, so F delta T equals the impulse, 11.5. And if the time is 0.003 seconds, F times 0.003, 11.5. The force then would have to be 11.5 divided by 0.003, which would give us 3,833 newtons. Okay, hopefully that's really making a whole lot of sense to you. You are now equipped to do questions 1 through 6 in your practice problems. And what I would like you to do for the rest of the period is work on those practice problems. There's no reason for anybody in here to be doing anything besides the practice problems, and you need the work time. So let's get busy and get those things done, and then have a really good weekend. By the end of the weekend, make sure that you've done those first 6 practice problems and help each other out on them. There's some tricky things that come up. You need to really think it through. Okay, God bless you and have a great weekend.